Hello class, today what we're going to talk about is solving radical inequalities. Right? So this is things like the square root of x is greater than 5 or something like that. So first what we're going to do is you just take the inequality and you solve it like normal, just like you would solve any other inequality. However, you do need to consider the domain, because if you remember, especially on square roots, okay, if you have a square root function, the number under the square root can't be negative, right? Because you can't take the square root of a negative number. So that is going to come into play here. So let's take a look at a couple of these. So here we want to solve 3 square roots of x minus 1 is less than or equal to 12. So we'd solve this the same way we'd solve anything else. Step 1, since this is a radical, we need to isolate the radical, so that 3's got to go away, right? So we would divide both sides by 3. Then we need to get rid of the square root, so we're going to square both sides. So we have x minus 1 is less than or equal to 16. Got to move that 1 over, so we add that to both sides. And we have x is less than or equal to 17. Right? Simple enough. However, this is a square root function, and we cannot have a negative underneath that square root. So that means that x plus 1 has to be greater than or equal to 0. Well, that's not too bad. We just add the 1 to both sides. So x has to be greater than or equal to 1. And what we're going to do with this is we're going to take both of these and we're going to put them together. Right? To work for the inequality, x has to be less than or equal to 17. To work just to get a number out of it, x has to be greater than or equal to 1. So we have both this. X has to be greater than or equal to 1. X has to be less than 17. So our solution, 1 less than or equal to x less than or equal to 17. All right? And here, if you look at this on the graph, here we have 12, what we're looking for. And here we have y equals 3 square roots of x minus 1. And we want this curve to be less than our straight line here, our constant function. And they intersect right here at x is 17. We want it to be less than, so that goes all the way down here. But you notice here, the curve stops. Our radical function, the graph stops. Because after this, we have imaginary numbers. And so that's no good. And so we only want from 1 up through x is 17. Okay? And that's why this happens and why we have to consider this radicand. Okay, so let's take a look at another one. So here we have negative 2 square roots of x minus 4 minus 5 greater than negative 11. Okay, so first we're just going to solve this like normal. Okay, so we need to isolate the radical. So that means this minus 5, the minus 2 has to go away. First things we're going to do is add the 5 to both sides. Deal with that negative 5. We add 5 to both sides. Next, we need to get rid of that negative 2 there. So we divide both sides by negative 2. And notice what happens here. Okay? Our inequality sign flips. Because remember, if you divide by a negative, you flip that inequality sign. All right? So that still comes into play. Just because it's a radical doesn't mean that we forget everything we've learned before. So there's that. Then we square both sides. So that gives us x minus 4 is less than 9. And so add 4, and we have x is less than 13. Okay, so great, that's it, right? No, not yet. Because remember, this x minus 4 can't be a negative number. That has to be positive. So we got to come over here and take a look at, where did I put it? Over here, there we go. X minus 4 has to be greater than or equal to 0. That gives us x greater than or equal to 4, right? Add your 4 to both sides. So there's that. That takes care of this being a functional thing, something that works. And what we're going to take these and put them together. So here we have x has to be less than 13, x has to be greater than or equal to 4. So we put that together, and 4 is less than or equal to x less than 13. Notice this time we have an equal to here, and a not equal to on the other one. All right. This here, this is always going to be greater than or equal to 0. Okay, so this is always going to be or equal to. This is going to depend on whatever the original problem was. Okay, and just so we can see the graph, here it is. Here is our radical. Here is negative 11. They intersect right there at 13, and this time we want this stuff up here. All right. Right here is where it's greater than negative 11, all the way up to there, and there the equation stops. Because after that, it's all imaginary, so it's no good. All right. So you've got to keep that radical in mind. Okay, so here we have a couple for you to do on your own. Work these two out. Pause the video, work these out, then come back and see how you did. All right, let's see how you did. There's your answers. Hopefully that's what you got. If you did, great, you're done. Good job. If not, let's see what happened. Okay, so let's take a look at A. We have 2 square roots of x minus 3 is greater than or equal to 3. So first we have to isolate this radical. So the 3's got to go away, the 2's got to go away. We'll take care of that minus 3 first. So we add 3 to both sides. Divide by 2. So square root of x is greater than or equal to 3. We got to get rid of the square root, so we square both sides. So 3 squared is 9. X is greater than or equal to 9. Okay, we do need to check out that radicand right there. Got to make sure that's good. So x, the stuff underneath here, has to be greater than or equal to 0. Well, if x is greater than 9, which is what we needed here, then it will also be greater than 0, right? And so that means this, in this case, isn't going to come into play. We don't care, because it's already going to be greater than that. It's going to be greater than 0. It's got to be greater than 9. If it's greater than 9, it's already greater than 0. So it's good. So it just has to be greater than 9. Okay, so let's take a look at B. All right, so there's our inequality. Isolate the radical, so that means we've got to get rid of this 4. So we divide both sides by 4. Gives us cube root of x plus 1 is less than 2. Then we need to get rid of the cube roots, so we cube everything. So x plus 1 is less than 8, so that's 2 cubed. Subtract 1 from both sides, x is less than 7. And on this one, you notice I didn't do anything to take a look at that radical, and here's why. This is a cube root function. On a cube root function, the domain is all real numbers. The radicand under here, this can be negative. We could have negative 1. The cube root of negative 1 is negative 1. That works. The cube root of negative 8 is negative 2. So since this is a cube root, this can be negative, so we don't have to work with checking it and making sure that it's positive. We don't have to mess with that. If we have a square root, then the radicand has to be greater than or equal to 0. But if it's a cube root, it doesn't matter. It can be negative. We don't care. All right. And so that's the only little wrinkle with solving inequalities with radicals. It's basically do it however you would normally do it. Just solve it like normal. But if you have a square root function, then you have to make sure that whatever is underneath that square root, the radicand there, is greater than or equal to 0. And once you do that, then you just take that into consideration. So, all right. Hopefully that helps, and I will see you tomorrow.